Hello everyone, welcome to Maybe Programming Club. Today we will be solving another daily Leetcode problem, and the problem's name is same tree. So given roots of two binary trees P and Q, you have to return a function that should check whether these two trees are same or not. Two binary trees are considered same if they are structurally identical and the nodes have same value. So in these two particular trees, both of them are having same structure. So if you draw their structures, they are pretty similar. Okay, so both of them is having this kind of structure. Okay, and the values at each corresponding node is also equal. So 2 is let's say if it is 2 here, then it is 2 here, and it is 1 here. If let's say, then it is 1 here also, and similarly 3 on the last node on both of these trees. So these trees are structurally equivalent or structurally equal, you can say. So your function should be returning true. Okay, so and let's have a look at another example also. So here you can see there are two trees which are not structurally equivalent. Okay, so if you see here that when the value was 2 here, it was 1 in the other tree, and when value was 1 in this particular tree, it was 2 in another tree. These two values were same, but these two values were making the difference. Okay, not same. So they are not structurally identical. Values are not same, but they are structurally identical. Okay, so these two conditions should be satisfied. So in order for the trees to be considered same, so these two trees are not same, because although they were structurally identical, but values were not same. Okay, on the nodes. So we should be returning we should be implementing a function that will return that. So it's pretty easy. If let's say one of the nodes is null, let's say P is null and Q is not equal to null, or let's say the other way around, and Q is equal to null and P is not equal to null, there can be this condition also, and P not equal to null. Okay, so in this case, both of these cases you should be returning false, because you know there is not even a structure in one of these trees to compare. So if that's not the case, and let's say both of the values of P and Q are null, okay, initially roots are given null to you, then you can safely say that okay, these two are identical trees, okay, or same trees, because you know we forgot to check the constraints also. It's mentioned that number of nodes in both of the trees can be from 0 to 100, 0 and 100 inclusive. So number of nodes in both of the trees can be equal to 0 also. So it means that P can be equal to null and Q can be equal to null also. Okay, so that's why these conditions are arising. Okay, so we will take care of these conditions, and other than that, if it's fine that neither P is null nor Q is null, then what you will be doing is, first of all, you will be checking whether P's value is equal to Q's value. Okay, this is case when P is not equal to null and Q is not equal to null also. Okay, so though both of these nodes are actually present, then we'll check their values. If they are equal, then it's fine. And other thing what will we check is we will recurse for left and right subtrees. Recurse for left and right subtrees. in both of these trees simultaneously, in both P and Q, simultaneously. Because if you do not do it simultaneously, you cannot compare their structural that they are structurally identical or the node values are same. Okay, so this is just a simple recursion. It will help us to solve this particular problem. So it's pretty straightforward if you ask me. So these were the conditions. When both of these values are null, then you will return true. Else if it is a condition that either of these are null, then in that condition you will return false. And if that's not the case, then you know that P and Q are both having non-null values. P and Q both are having non-null values. Okay, so it means that both of these nodes exist, and then you will check whether the values are same or not on both of these nodes. Then you will recurse for the left subtree and for the right subtree also. If you want, I can write it in a more verbose way. So you can write here bool left subtree check, you can say. Okay, and other one you can say right subtree check. This one is your right subtree check, and then you have to just return a combination of this left subtree check and then right subtree check. Okay, let's try to submit. Okay, there is some kind of error that we have done. What that error be? Okay, we have not provided the semicolon here. Yeah, as you can see that at least sample test cases are passing right now, and you can see that it's getting accepted also. So that is how you will be solving this particular problem. If you ask what will be the time and space complexities here, so space complexity wise, you can say that whatever will be the maximum depth, common depth of these two trees, that much space will be required for your recursion. And if let's say you want to know the space complexity part, so it will be order of n only, where n is the number of nodes, you can say, in the trees. Okay, so thank you for watching. Have a great day ahead.